Simplifying systems of forces. This is going to feed into distributed load, center of mass, and a few concepts in the future that we're going to be going over. And the idea is we don't want to have to keep track of every force on every single little atom in the system. We want to take a bunch of forces, add them all together, and create just one simple equivalent force out of it. So we're simplifying systems of complicated forces. And we're going to start out with just a very simple example where we're going to combine forces and moments on a beam to just one force and one moment. Combining multiple forces into just one force. So all we're doing is just 200 plus 300 equals 500. We just add together all the forces on the system and we're just going to use the resultant of those forces. We also need to find an equivalent moment as well as the forces. Now, if we're going to apply that 500 resultant force at point A, we need to account for that 200 not being over there at the end of B. That created a moment around A before, and we want the same thing on each side of that equal sign. So 200 times 3. Moving that 200 force, we have to still keep that 600 Newton meter moment. Combining all of the moments into just one moment, we end up with 600 plus 400, 1,000 Newton meters. So just like we added all the forces together to get that 500, we're adding all of the contributions to the moment together to get that 1,000. Now this is also with respect to A, so we have to worry about where we were taking those moments around and where we were applying that new resultant force. Let's just work a few of these out in Excel. All of these examples all have a bar that's 3 meters long, and we're just going to be adding together all the forces for each case and adding together all the moments for each case. The moments are calculated with respect to point A, so consider A as the axis of rotation for all of these systems. That means we don't need to worry about the force at A because that position vector would be 0. We just worried about that 200 times 3, and then we're going to add that 600 moment to what is applied, which is 400 in this one. For each one of these, just add the forces together and then decide on the moments. So 300 times 3, make sure you have the signs right. Counterclockwise is positive, clockwise is negative. This is a lot of repetitive work here, but the more examples you see, the more this will become just intuitive. You don't want to just understand it, you want it to be intuitive. So you glance at it and you can visualize what's going on and what that equivalent force is. So again, add up the forces, add up the moments, and check those signs. You can write the signs as either positive or negative, or just draw an arrow next to your answer showing which way it's rotating. So again, negative would be righty-tighty going back into the board, versus a positive moment is counterclockwise or unscrewing out forward in the board, or you can use the right-hand rule. The other part of this is finding two systems that both have the same equivalent forces. So you can see all of the different combinations of forces and moments that can all add together to the overall same result. This is also just some really good practice to get used to calculating moments. The more example problems you solve, again, the more familiar you'll be and the easier all of this stuff will become. And once you're solid with these simple systems, the next distributed loads and center of mass and more complicated systems, they won't seem so scary to you. They'll just be more of the same thing, just keeping track of more stuff.